Hey folks, this is 6.5b. Well, you probably can't see that. I think that's 6. Yeah, sure enough. 6.5b, here we go. So the directions say, find all the zeros of the polynomial function. One zero has been given. The zero right here is -2. So we're going to use synthetic division to figure out what the remaining polynomial is after I divide by x plus 2. Because this comes from x plus 2. When we were doing the long division, we were actually the same as saying, hey, take this polynomial right here and divide it by x plus 2. X plus 2 has a 0, or what makes this value become 0 what value to plug in for x to make it become 0? The answer is -2. So -2 is a 0. So take your coefficients of the polynomial 1, 11, 38, and 40, and let's do this. Drop your leading coefficient down. Let's try that again. Drop your leading coefficient down, multiply, add, multiply, add, multiply, add. Good. What's good is I should have gotten a 0 here for my remainder, which means that x plus 2 truly is a factor of the polynomial. Now so if x plus 2, is a factor, the other factor right now that is, well, let's see, this is the remainder, so this is the constant. This is your x term. That makes that a positive 20, or this is a positive 20, right? This is a positive 9, but we put an x with it. This is a positive 1, and we have an x squared in front of that. So x plus 2 is one factor. The other factor, I got to be careful how I say that though, the other factor is is x squared plus 9x plus 20. But now, folks, we need to try to further this factor this further. There we go. We're looking for numbers that multiply to 20, because this is the a equals 1. This is the quick method. Numbers that multiply to 20 and add to 9, that would be 4 and 5, right? So that means that this polynomial, which I'll highlight right now in yellow, can be factored further into x plus 4 times x plus 5. And then because -2 is a 0, that means that came from the factor x plus 2. Right? Because once we have it in factored form, it's easy to find the zeros. We know that a factor is -2, though they already told us that, because we're setting all of these factors equal to 0. So x has to equal -2. We already knew that. What makes this become 0? X has to equal -4. What makes this become 0? X has to be, let's see, -5 plus 5 is 0. So -5 is a solution. I got that from the factored form. Boom, shakalaka. And oftentimes they'll put the answers just with commas in fancy pants brackets. -5, -4, -2. Of course, we already knew the -2. Let's try it again. Now, if 3 is a factor, if 3 is a 0, because 1 0 has been given, and that's what they're alluding to right here, that comes from the factor of x minus 3, because 3 minus 3 is 0. So 3 is the value that makes x, or is the value of x that makes the function become 0. So let's synthetically divide to figure out what our remaining polynomial is. Now notice here we don't have a constant term, so we have to put a 0 at the end. We're still going. So drop your 1 down, multiply, add, multiply, add, multiply, add, multiply, add. Good. What's good is that my remainder is 0, which means that this truly is a 0. 3 truly is a 0, or a solution to that. So then, what's my remaining polynomial? Well, this becomes the constant. The next term is the x. It's a -10x. The next term is the x squared. It's a -3x squared. And then the next degree up from that would be x to the third, actually. Crazy. So, right now, I know that one factor was x minus 3. Because remember they told us that 3 is a 0? That comes from, that automatically tells you that x minus 3 is a factor. Well, this times this equals the original polynomial. So I need to take that x minus 3 times what I got from my remaining polynomial after I synthetically divided. So then, folks, we always take the remaining polynomial, like in the last problem, and try to factor that further. Well, from that yellow factor, I can factor even further. First of all, I can factor an x out of there. And then when I factor an x out of there, I'm left with x squared minus 3x minus 10. So then I want to further, so just to kind of color code this, what's in yellow is equivalent to what's in yellow. But now if we kind of look at this polynomial, that x squared minus 3x minus 10, I got to try to factor further, right? So we're looking for numbers that multiply to negative 10. Where should I do this work? I guess over here. Negative 10 and add to negative 3. So it means that one's positive and one's negative since it's a negative 10 for a product. There we go. So x minus 5 times x plus 2. And then we also have this factor of x and this factor of x minus 3. So they want us to find all the zeros. Well, so again, that means what values of x make the function equal 0. So what makes this equal 0? Well, x would have to be 3. This one's kind of silly. What makes this factor become 0? 0. What makes this factor become 0? What do you have to plug in for x? Well, 5, because 5 minus 5 is 0. What do you have to plug in here? A negative 2, because negative 2 plus 2 is 0. So then we put those in fancy pants brackets. There we are. Sweet. Number 3. If one of the zeros is positive 3, that comes from the factor of x minus 3. So just keep that in mind. We're synthetically dividing with 3 or substituting 3 in. So our coefficients are 1, negative 3, negative 25, and 75. Notice that no terms have been skipped, so I don't have to worry about putting a 0 in. And then we drop the leading coefficient down, multiply, add, multiply, add, multiply, add. Good, we got a 0. This is the constant, so this is like the remainder. This is the constant, this is the x term, this is the x squared term. So really we have x squared minus 25 for this part right here. Of course, one of our other factors is x minus 3, because if 3 is a 0, that comes from the factor of x minus 3. By the way, folks, so then you know that we try to factor this remaining polynomial further. It's only got 2 terms, so here I'd be thinking of difference of squares, because I know I can square root both of those terms. You get x and 5 for the square roots of each of them. So you get x plus 5 times x minus 5 in factored form. And then drop down your x minus 3. So what are our zeros? What makes each of these factors equal 0? 3 makes this become 0. Negative 5 makes this become 0. And positive 5 makes this become 0. Sweetness. Let's try it again. Negative 5 comes out in front. We've got 1, negative 25, 25, and 0. Drop the leading coefficient down and multiply and add and multiply and add and multiply and add and multiply and add. Good. We have a remainder of 0. This is our constant term. This would be our x term. This would be our x squared term. It's a negative 6x squared. This would be our x to the third term. So let's think about, where did if negative 5 was our 0, where'd that come from? What was the factor? It came from x plus 5. So this polynomial is equivalent to x plus 5 times x to the third minus 6x squared plus 5x. So now we try to factor that remaining polynomial further. Notice, always look for a GCF. All of those terms have an x in it. So out of that green highlighted polynomial, I can factor an x out. And then I'm left with, if you really just lower these degrees by 1, that becomes an x squared. That becomes an x. And this one's gone then. Whoa. Don't x out the x. It looks like just a big x. So we're looking for numbers that multiply to positive 5 and add to negative 6. Now, if it multiplies to positive 5, that means either both numbers are positive or both numbers are negative. Well, two positive numbers don't add to a negative, so they both have to be negative. A negative times a negative is a positive. And when you add up a couple negatives, you get a couple bills, a couple IOUs, that adds up to a bigger negative. So negative 1 and negative 5 are the values that work there, so that translates to x minus 1 times x minus 5. Let's find the zeros. What makes this function equal 0? Well, let's see here. Negative 5 makes this factor become 0. 0 makes this factor become 0. 1 makes that become 0. 5 makes that last factor become 0. It's a bad fancy pants bracket. Let me change that. That bothers me. There. Oh, okay. Here we go.